Welcome back to the channel. Today, we're going to explore some really important skills that will help you understand and analyze information, which is an important skill on your GED Social Studies exam, and even more important, useful in everyday life. We'll start by looking at how to read and understand graphical data, especially when it's related to historical events and political changes. We'll also discuss how you can tell the difference between dependent and independent variables, so you can clearly see the cause and effect relationships in topics like population growth and economics. All these skills are designed to help you become a more informed
Hmm?
citizen, capable of interpreting the world around
Ah,
you effectively. So, let's get started with question 1, which is about interpreting graphical data. Take a look at the graph showing the number of women in the U.S. House of Representatives from the 101st to the 115th sessions. All right, let's break this graph down in a way that's clear if you're new to graphs or you just have trouble interpreting graphs in general. Take a look at this graph. It's showing us the number of women serving in the U.S. House of Representatives over different sessions of Congress. This is a bar chart, which is a great way to visualize trends over time. Now let's start at the top. The title tells us exactly what we're looking at, how the number of women in the House has changed over time. Next, look at the x-axis, which is the horizontal line at the bottom. The labels, 101st, 105th, 110th, and 115th, represent different sessions of Congress. Each session lasts 2 years, so what we're seeing here is how things have changed over multiple election cycles. Now, shift your attention to the y-axis, the vertical line on the left side. These numbers represent how many women were serving in the House. The higher the number, the more women were in office during that particular session. Now let's talk about the bars themselves, those vertical rectangles in the chart. Each bar represents a specific session of Congress, and the height of the bar tells us how many women were in office at that time. The taller the bar, the greater the number of women serving in Congress. And what do you notice? The bars keep getting taller from left to right, showing a clear upward trend. So, what does that mean? This graph suggests that the number of women elected to the House has been steadily increasing over time. For example, if you look at the first bar on the left, representing the 101st Congress, you'll see it's much shorter than the bar on the far right, which represents the 115th Congress. This tells us that over the years, more and more women have won seats in the House of Representatives. Now, let's be mindful of a few things when interpreting this data. First, this graph shows us a trend, but it doesn't explain the reasons behind it. There could be many factors at play: policy changes, shifting public attitudes, or efforts to encourage more women to run for office. It's also important to note that this graph only looks at the House of Representatives, not the Senate or state legislatures, so it's just one part of a bigger picture. That being said, the upward trend is clear. If this pattern continues, we can expect to see even more women serving in Congress in future sessions. But of course, past trends don't always guarantee future results. Elections can be unpredictable. So, in summary, this graph shows that over time, more women have been elected to the U.S. House of Representatives. It's an encouraging sign of change, and it will be interesting to see if this trend continues in the years ahead. Now, pause the video and take a moment to carefully review the data. Okay, now that you've reviewed, let's think about what the question is asking. Which session experienced the largest percentage increase compared to the 101st? Notice, it's not just asking which session had the most women, but which had the biggest percentage growth. Remember, when you see percentage increase, you're thinking of proportional growth, not just raw numbers. To answer this, compare each session's numbers directly against the 101st. If you chose the 115th session, option C, you're thinking about it correctly. This session showed the most substantial increase compared to the starting point. Options A, B, and D either didn't have as large an increase or incorrectly suggested they were equal. Now let's look at question 2, which is about dependent and independent variables. The scenario describes a city whose population grew significantly, and researchers are looking at what affected this growth. The question asks, If you're testing how the growth in industrial job openings affects the city's population, what's your independent variable? All right, let's talk about dependent and independent variables in a way that makes sense without overcomplicating things. Whenever you're looking at cause and effect, there are always two parts: something that changes and something that responds to that change. The thing you control or manipulate is the independent variable. It's the factor that sets everything in motion. The thing that reacts or changes as a result is the dependent variable. It's what you measure to see the effect. Think of it like a chain reaction. The independent variable is what starts the process, and the dependent variable is the outcome that follows. The key is right in the names. The dependent variable depends on what happens to the independent variable. This relationship is at the heart of experiments, research, and even everyday situations where one thing influences another. If you ever find yourself trying to figure out which is which, just ask, what's being changed? And what's being measured? The answer to the first question is the independent variable, and the answer to the second is the dependent variable. The independent variable is always the one you think is causing the change. Take a moment and think, what are we testing as our cause here? If you chose C number of industrial job openings, you're exactly right. This is because job openings are what's being tested as the potential reason, cause, behind the city's growing population, effect. Other choices, like the city's population or household income, would be effects, not causes, or unrelated variables. You're correctly identifying that job openings influence population size, not the other way around. Moving on to question 3, this one tackles correlation versus causation. It mentions farmland dedicated to wheat increasing significantly over a period, while family size also increased. The question is asking you to recognize what's merely correlation, where two things happen together, but not causation, meaning one thing directly causes the other. Understanding the difference between correlation and causation is important because it helps us avoid jumping to conclusions about how things are connected. Correlation happens when two things seem to move together. If one increases, the other does too, or if one decreases, the other follows. But just because they happen at the same time doesn't mean one is causing the other. It could be a coincidence, or there could be a hidden factor influencing both. Causation, on the other hand, means that one thing directly affects another. If one factor changes, and it actually causes the other to change as a result, that's causation. It's a much stronger relationship because it's not just about patterns, it's about cause and effect. A big mistake people make is assuming that just because two things happen together, one must be causing the other. But correlation alone doesn't prove that. Sometimes there's an outside factor at play, or it might just be a random pattern. The key is looking for real evidence that one thing is actually making the other happen, not just that they appear linked. So pause and reflect here. Which statement shows correlation without proving one caused the other? If you selected C, you're exactly right. Both increased, but there's no proven cause and effect relationship. Options A, B, and D incorrectly imply direct causation. So the best answer here is clearly C. Wheat acreage and family size both grew, but we cannot conclude one caused the other. This illustrates correlation perfectly. Two things happening together without clear evidence of causation. The other options suggest causation, but we simply don't have enough evidence to claim that from the provided data. The key to understanding this answer lies in the difference between correlation and causation. In this scenario, both the amount of farmland used for wheat and the average family size increased over the same 20-year period. This means there is a correlation. Both numbers are rising together. However, we cannot conclude that one caused the other. Remember, just because two things happen at the same time doesn't mean one is responsible for the other. For this to be causation, we would need evidence showing that increasing wheat acreage directly led to larger family sizes, or that growing families somehow caused more wheat to be planted. But there's no clear reason why these two things would be directly connected. Instead, there could be an outside factor influencing both, such as economic growth, changes in land use policies, or shifts in population trends. So while the data shows a relationship, it's simply a correlation, not proof of causation. Without further evidence, we can't say that one caused the other. We just know they happened at the same time. Question 4 is about political vocabulary. Social studies vocabulary is important for you to review, as the GED mentions it as one of the specific skills for the exam. You'll be presented with social studies passages, which include common social studies, terms, and phrases. Here is one way you can figure out the meaning of the word. The word is bipartisanship. Pause and think about the root words bi, partisan, and ship. We're looking at understanding political terminology using root words and suffixes. The term we're analyzing is bipartisanship, constructed from bi, meaning two, partisan, aligned with a party, and ship, meaning the condition or state of something. So, the best choice here is C, the state or practice of two parties working together. The other answers aren't correct because they either misunderstand the term or incorrectly explain the root words. Did you pick option C? Perfect. You're understanding that bipartisanship means two parties working together. The other options suggest meanings that don't align with the parts of the word. Next, question 5 involves federalism. Using context clues from the excerpt, pause the video and determine the core principle described. We're given an excerpt about federalism. It mentions dividing powers between central authority and states. So what's the core idea here? You're looking for the main principle that defines federalism. Answer C is correct, because federalism is all about shared powers and overlapping responsibilities. Answers A, B, and D incorrectly describe federalism, either giving states no power, centralizing all power, or wrongly assigning power exclusively to the central authority. Federalism means power is shared between levels of government. The other options incorrectly imply either no state power or total centralization. Question 6 looks at cause and effect during the Great Depression. Pause to consider which event led directly to others. Remember, cause and effect is about understanding how one event leads to another. In the context of this question about the Great Depression, cause refers to something that sets events in motion, while effect is the result or consequence of that cause. For example, the stock market crash of 1929 is a cause. It triggered financial instability. One major effect of that crash was that banks started failing because they couldn't return people's money. This, in turn, led to high unemployment, which then caused many families to lose their homes. In response to these hardships, the government created new programs to help jobless citizens, another effect of the economic crisis. The key to identifying cause and effect is looking for a clear chain of events, where one thing leads to another, rather than just happening at the same time. In this case, the stock market crash didn't just happen alongside bank failures and unemployment. It directly contributed to them, making it a clear cause and effect relationship. So if you chose D, you got it right. The stock market crash directly caused unemployment to soar and led to new programs. The other choices reversed or misrepresented this relationship. Let's discuss question 7 about statistics. The median. We're given county populations and asked for the median. Once more, let's review the chat to ensure that we understand what it is saying. This graph shows the population of 5 counties in a bar chart format. Let's go through how to read it step by step. First, look at the title at the top. It tells us exactly what this chart is about, the population of 5 different counties. Now, let's move to the x-axis, which runs along the bottom. This axis lists the names of the counties: County A, County B, County C, County D, and County E. Each county has its own vertical bar. Next, check the y-axis, which runs up the left side. The numbers here represent population, measured in thousands. So, for example, if a bar reaches up to the 60 mark, that means the population of that county is 60,000 people. The bars themselves represent the population of each county. The taller the bar, the larger the population. By comparing the heights of the bars, you can quickly see which county has the most or the least people. For example, you can see that County A has the smallest population, while counties B and E have the largest since their bars are the tallest. The other counties fall somewhere in between. To interpret this graph correctly, focus on the relative heights of the bars rather than just the exact numbers. The chart makes it easy to compare populations at a glance, rather than listing numbers in a table. So back to the original question. What is the median population among these 5 counties? The median is the middle value in a set of numbers when they are arranged in order, from smallest to largest. If there's an odd number of values, the median is the exact middle number. If there's an even number of values, the median is the average of the 2 middle numbers. The importance of the median comes from how it represents the center of a data set in a way that isn't affected by extremely high or low values. Unlike the mean, or average, which can be skewed by outliers, the median gives a more balanced picture of what's typical in a data set. For example, in measuring income, a few very wealthy individuals can raise the average, making it seem like people earn more than they actually do. The median, on the other hand, provides a better sense of the typical income level because it isn't influenced by those extreme values. That makes it especially useful in statistics, economics, and other fields where understanding the true middle point of a dataset is important. So what would be your answer here? Remember, the median is the middle number once data is ordered from smallest to largest. Arranging the populations, we get 45, 60, 75, 90, 90. So the median is clearly B, 75,000. Option A and C are either lower or higher than the middle value, and D is incorrect because it's not an actual listed population. Now on to question 8, interpreting a political cartoon. The cartoon shows Party A, the donkey, trying to move forward with an infrastructure bill, while Party B, the elephant, blocks the path. Pause and reflect. What is the cartoonist implying? Clearly, the cartoonist is suggesting B. Political Party A is trying to push a public works proposal, while Political Party B impedes it. Other options misinterpret the visual message or context. If you chose option B, you're right. Party A tries pushing a bill, while Party B blocks it. Other options misrepresent the cartoon's message. Now for question 9, we are given a line graph, which is interesting. Do you know how to read this type of chart? Reflect on the others we have done so far, and see if you can interpret this chat on your own before we go through it together. Pause and reflect. This graph is showing us 2 things over time: greenhouse gas emissions and global temperature changes from 1950 to 2000. The idea is to see how both of these have changed over the years and whether there's a pattern between them. First, let's look at the bottom of the graph, where you see the years listed from 1950 to 2000. That tells us we're looking at a timeline of how things have changed over 5 decades. Now, moving to the left side, you'll see numbers going up. This is measuring greenhouse gas emissions in millions of tons per year. The higher the number, the more emissions were released into the atmosphere. On the right side, there's another set of numbers, but this one is measuring global temperature changes, or how much warmer or colder the Earth was compared to an average. Now, let's focus on the 2 lines in the graph. The blue line represents greenhouse gas emissions. It starts low in 1950 and steadily rises over time, meaning emissions have been increasing. The red dashed line represents global temperatures, and just like emissions, it also moves upward, showing that temperatures have been increasing over the same period. So what does this tell us? Both greenhouse gas emissions and global temperatures have gone up over time. This means there is a correlation, meaning they seem to be increasing together. But it's important to remember that just because 2 things happen at the same time, it doesn't automatically mean one is causing the other. Other factors could be at play, and scientists look at more evidence to determine whether rising greenhouse gases are directly causing the rise in temperature. The key takeaway is that over these 50 years, both emissions and temperatures have been on the rise. The graph shows the trend clearly, but to fully understand the connection, more analysis is needed. It's a useful way to visualize the data and start thinking about the relationship between human activity and climate change. Notice the question asks about the most accurate conclusion from two rising trends. Pause and ask yourself what conclusion the data most accurately supports. The correct answer here is B. There's a positive correlation between emissions and temperatures. It acknowledges the data without overstating causation. Option A incorrectly assumes direct causation without other factors. Option C ignores evidence, and D assumes immediate proven causation without sufficient evidence. Now, question 10 gives us a humorous example about pirates decreasing and global temperatures increasing. First, let's take a look at this table and break it down in a simple way to ensure that we understand how to read it. First, look at the top row of the table. This is called the header row, and it tells us what each column represents. There are three columns in this table: year, number of pirates, estimated, and average global temperature, degrees Celsius. Now, let's start with the first column, year. Since year is written at the top, everything listed underneath it represents different years. The table gives us data for 5 years: 1800, 1850, 1900, 1950, and 2000. These years are written in order from oldest to most recent, so we can see how things change over time. The second column, number of pirates, estimated, tells us how many pirates were believed to exist in each of those years. If we follow the numbers down, we can see that in 1800, there were 50,000 pirates, but by 2000, there were only 2,000. This means the number of pirates has gone down over time. The third column, average global temperature degrees Celsius, shows the Earth's temperature in each of those years. Looking down this column, we see that in 1800, the temperature was 14.0 degrees Celsius, but by 2000, it had risen to 15.0 degrees Celsius. This means that while the number of pirates was decreasing, the Earth's temperature was increasing. Now, when reading a table like this, the key is to look across each row to see the full set of information for a given year. For example, if we look at the row for 1900, we see that there were 30,000 pirates, and the global temperature was 14.3 degrees Celsius. If we move to the row for 1950, the number of pirates had dropped to 15,000, and the temperature had risen to 14,6 greater Celsius. At first glance, it might look like there is a relationship between the number of pirates and global temperature, because as one goes down, the other goes up. But this is actually just a coincidence. There is no real connection between pirates and climate change. The table is a great example of why we should always be careful when interpreting data. Just because two things happen at the same time doesn't mean one is causing the other. So, when reading a table like this, always start by looking at the column titles to understand what information is being shown. Then, read down each column to see how one specific thing changes over time, or read across a row to see all the information for a single year. This table is comparing two things over time: the estimated number of pirates in the world and the average global temperature. It gives us data from 5 different years: 1800, 1850, 1900, 1950, and 2000. Now that we understand the table, let's revert to the question: which statement best describes this scenario? Remember, correlation isn't necessarily causation. In question 10, the quirky example of pirates and temperatures tests understanding correlation. Pause to consider. Does fewer pirates cause global warming? Choosing C shows you're thinking critically. There's correlation, but no proof of causation, despite the humorous implication. Question 11 addresses demographic data and voter preferences. This table is showing information about the population and voter registration trends in City X over a decade. At the top, the title City X Population and Voter Registration tells us exactly what the table is about. Below that, there are 4 columns, each representing a different type of data. The first column is labeled Year, which tells us when the data was recorded. Since Start of Decade is listed in the first row under this column, Everything in that row represents data from the beginning of the decade. The second row, labeled End of Decade, represents the data from the end of that same decade. This lets us compare how things changed over time. The next column is Population, which shows how many people lived in City X at each point in time. At the start of the decade, the population was 50,000, and by the end of the decade, it had grown to 80,000. This means the city's population increased significantly over those years. The next two columns show voter registration percentages for two political parties, Party A and Party B. At the start of the decade, 60% of voters were registered with Party A, while 35% were registered with Party B. By the end of the decade, Party A's percentage had dropped to 50%, while Party B's percentage had risen to 45%. This table helps us see two trends happening at the same time. First, City X's population is growing. Second, voter registration is shifting, with fewer people registering for Party A and more people registering for Party B. The table makes it easy to compare these changes side by side and understand how things have evolved over time. Now that we have broken down the table, pause to reflect on what the population and voter changes suggest. If you chose C, excellent analysis. New residents are likely joining Party B or third parties, reducing Party A's overall percentage. Finally, question 12 asks about third parties in the U.S. political system. Pause and reflect. What role do these parties typically play? Here, we're defining what a third party means in U.S. politics. Third parties typically have less support, but can influence the main parties. The correct answer is B, exactly for this reason. Other choices exaggerate their impact or misstate their function. Remember, when approaching these questions, carefully analyze graphs, charts, and context clues. Always clearly differentiate correlation from causation. Carefully think about dependent versus independent variables, and dissect word meanings based on root words and suffixes. Use the comments section to let us know how many you got right. Feel free to rewind or pause this video whenever you need to review or think things through. Keep practicing these strategies, and you'll be prepared for test day and beyond. I'll see you again soon for more GED Social Studies practice. Be sure to like and subscribe to get notifications when we post videos.